Okay, now we're going to look at composition of functions. Composition of functions refers to using the output of one function as the input of another. So we're using multiple functions in sequence. Let's go back to our function where we had superheroes as our inputs and their secret identities as our outputs. We called that the secret identity function. And that means that we could call these values, instead of calling them our y values, which would be fine, we could also call them our secret identity of x values, because they are outputs of the secret identity function when we put x in the values over here as our inputs. Now suppose we use these as the inputs for another function, the job function. This function takes an input here and finds their job and returns that as an output. So Clark Kent's job is a journalist. The job function would take Clark Kent as an input and give journalist as an output. Similarly, it would take Peter Parker as an input and give photographer as an output. Bruce Wayne, it would take as an input, and as its output, it would give CEO of Wayne Enterprises. So the job function is going to return the job of the input. Now, if we started from the left and worked all the way to the right, we could put Superman into this double function now, job of secret identity of X, and get out journalist. By putting Superman in here, where the X is, first this would take the secret identity of Superman, give us Clark Kent, and then take the job of Clark Kent and give us journalist. So this kind of nested function, or composed function, or composite function rather, is going to take an input and then run it through several functions in sequence. Notice that order is important here. We have to do secret identity first before job. It doesn't make any sense to do job of Superman and then find the secret identity of the job of Superman. So it's important that we have it in this order. Let's take a look at some more mathematical examples. Say we were given f of x is equal to x squared and g of x is equal to 3x. And we applied them in sequence. First we applied f and then we applied g. So in that case, we put 1 in here and we square it, we get out 1. We put 2 in, we square it, we get out 4. 3 squared is 9, 4 squared is 16. Now the g function is going to multiply all those numbers by 3 and give us this output here. Now this could be called the g of f of x function. It's a composite function made up of first doing the f function first and then the g function second. Now again, notice that order is important. If we did them in the opposite order, the g function, the tripling function first, we put in 1, 2, 3, 4, we get out 3, 6, 9, 12. And then if we apply the f function, the squaring function, we get out 9, 36, 81, and 144. So totally different results than we got up here. So f of g of x is not equal to g of f of x. Order is important. Also notice that we are working from the inside out. First, we applied the g function in this bottom case, and then we applied the f function. So we put the g function on the inside and then the f function. The whole output g of x becomes our input for the f function. So we write it like that. So the points to remember, so there are a couple of points to remember rather. First of all, there's two ways of indicating composition. This is the most common one that we will use, g of f of x. But some textbooks will use this notation as well with the little open circle in the middle, g of f of x. So you should be familiar with both of them, although you'll see this one more commonly. Also, in both cases, we're working from the inside out. These mean the same thing. You would always apply the f function first and then the g function next. If it was written f of g of x, you would do the opposite. Apply the inside one, the g first, and then the outside one. But in this case, g of f of x means apply f first and then apply g. In the next video, we'll take a look at some examples of how to do this.